I think I'm live now. Can anyone confirm if audio, video, etc. everything is fine before we get started? Like I'm experimenting with the new setup. Do let me know if something is off. I can try fixing it. Okay, looks like system testing has started. Okay, I think I'm live now. Can anyone confirm if audio, video, etc. everything is fine? And like people in the chat, like how many problems were you guys able to solve today? Okay, A, B, what is the edge case in second? Missed many cases in B. Like, to be honest, I found B tricky one. Like, although I was able to solve it, but it's a tricky problem to be honest. Like, if you look at me, like the way I solved it was A, D, B, C, and then E. Yeah, I think I will start with problems now. So, like the first problem says MEX Destruction. Every the dragon found an array A1 to AN of n non-negative integers. In one operation, they can choose a non-empty subarray B of A and replace it with the integer max of B. You want to choose this operation any number of times to make A contain only zeros. It can be proven that this is always possible under problem constraints. The problem is what is the minimum number of operations required. Some definition is also given here, like an array C is a subarray of array D if we obtain C by deleting some numbers from starting and some numbers from end. And max minimum excluded number of some integers is defined as smallest non-negative integer which does not is on collection F. Like for example, we have some cases here. Like let's say we have 0, 3, 0, 4, and 5. The max of this array would be 2, because if you see, like 2 is the smallest number that is not present in this array. Similarly, let's say if the array is like this 2, 1, 3, 0, 4, 6, then the max would be 6. And then the problem statement says, like let's look at one of the example here. Like for example, first problem statement is, first example is 0, 1, 2, 3. Like what is the worst case answer? Let's try to see. Like what we can do is we can pick the whole array once. We will get one integer. In worst case, this integer can be 0. In that case, we are good. If let's say the max of the complete array is 5, then now we can pick this element again and try to find max of this array, and we will get 0. So the worst case answer is we can say always less than equal to 2. Any reason why, or any questions on this? Why the answer is always less than equal to 2? Like the answer is always less than equal to 2 because in the worst case what we can do is we can take the complete array. We can find the max, like the number which is missing in that. If that number is 0, we are done. If that number is not 0, then we will get only one number which will not be 0. And now if you try to find max of single integer, you will always, which is not equal to 0, you will always get 0. So like the problem reduces to checking if the answer can be 0 or 1. So what we have to do is check if answer is 1. If this is to print it, otherwise check answer equal to 1. If answer is 1, print it, otherwise just print 2. And essentially that would be our solution here. Okay, how 5? I think I should have not erased it. But yeah, probably the max value can be different. I have not really looked at what the max was. So it can be something else too. Like 5 was just one random number there. So like when is answer 0? Answer is 0 only when all the numbers are 0. So this case is simple to check. Like we can check if the array contains already 0 all the time. Now the idea is when can answer be 1? The idea is like let's say you will have some numbers like this 0, 0, 1, 0, 0, 2, 0, 0, 3, 4, etc. Now to delete all the numbers except 0, you will have to pick all the numbers which are non-zero and any 0 that appears in between. Like pick the first number which is not 0, pick the last number which is not 0, and try to replace everything in this range with whatever value we have. If this range does not contain 0, then you will get max as 0. And you are done with one operation here. But let's say if this sequence contains 0 or something like that, then what you will get is something max which is not equal to 0, and then you can apply whatever number here is with one more operation to get max 0. So the answer is 1. Answer is 0 if all the numbers are 0. Answer is 1 if zeros exist only in starting and only in the end, not between any two other numbers. And essentially this is what basically you find the index of first non-zero element, find the index of last non-zero element. There should not exist any 0 between these two numbers, and that was the idea for this problem. And if answer is not 0, answer is not 1, directly print answer 2. So that was the idea. I think let me just pick some simple solution implementation here. So what, okay, like Rubicon did was, yeah, I will move to B once I'm done with it. Okay, what he did was he found all the index of all the elements which is not 0. Then he looked at like if all the numbers are 0, print 0. Then one smart thing he did was he looked at the first element which is not 0 and the last element which is not 0, and that is the range. And if that range is equal to all the number of elements you have, then you can assume that there is no 0 in between and print 1 there, otherwise print 0 there. Any questions on the first problem before you move on to next problem? Yeah, you can even brute force over here, or you can even try taking elements. You can also try all the range from L to R replace them with their max and see if that makes everything zero. That can be more solution here. Like the constraints are n is up to 500 and this is up to 50 only. Okay, like now we move to problem B. Like I think there are no edge cases here. You might have to be a bit careful about how you implement it. Okay, problem B says given a string s1 to n of length and consists of character p, s, and dot. Determine whether a permutation p of length n exists such that for all the integers I, if si is p, then first I element forms a permutation of length I. If si is s, then all the element from I to n form a permutation of this length. And if si is dot, we do not have any condition over here. So some examples here. Like for example, let's take one of the input here, which says s dot sp. And like one claim is like this array will work here 3 4 1 2. Now if you look at this s says all the numbers from this to this should be a permutation of length 4. And like permutations are numbers, like a length L permutation is a permutation which contains all the numbers from 1 to L, and there are no repetitions as well. So you see like 3 4 1 2, like this is a permutation of length 4. This as also says like last two numbers should be a permutation of length 2 here, and you see 1 and 2 are also permutation here. And this p means all the numbers from here to here should be a permutation of length 4, and you see like this is also a permutation of length 4. So we have to just print if L2 are like for all the given index whether a permutation a valid array exists or not. So any ideas on what to do this on this one? Okay, the first idea I have is like what's like let's just ignore all the p and just look at only s. Let's just look at x here. My idea is ignore p and dot and try to create a permuted valid answer and try to make it as good as possible. For example, here you know that this part, like let me just replace p by s once. Like because this p exists, we know that all the numbers from 1 to 3 should be here. And what is the best case we can do so that it can potentially satisfy here? Like we replace it with 1, 2, and 3. We can get any other combination as well, but I think this would be best because this will ensure that all the s which appears before it are also valid. And then the next idea is now I proceed further. I found one more p here. I have already replaced numbers up to 3 here. So my idea would be I replace here with 4, 5, and 6. This is the best I can do to ensure that all the numbers from 1 to 6 are permutation, and putting it in reverse order ensures that we can potentially satisfy the constraint due to s as well. And then we also have a p again here, so my idea is replace here with 7. Now we have a dot, so fill all the numbers in decreasing order again here. 8 9. By just looking at p and dot, by just looking at p, I think this is the array, one of the valid array, and this is the best I can probably do to ensure that probably s condition is also satisfied here. That's what I did. I created one array like this, and then I started from reverse and check is the condition due to s satisfied here. Like now I iterate from here. And you see, like, this should be a valid array, valid permutation because of this s. But you see, like, this is not a permutation, 3 exists. So the answer for this string would be no. And like essentially that was the idea I had. Now to iterate from the suffix and check if a valid permutation exists or not, there are many ways to do it. You can just, since you are filling the array, you know like what would be the valid array here. Like you can brute force it because n is up to 5,000. Or you can also, and because you are filling the array, you know that you will fill only numbers between 1 to n, and final value would be a permutation. So you can also look at the sum if it's equal to like sum of first one numbers 1 up to l, if this is the length L permutation. So that is the thing you can do here. And this was my idea for this problem. Any questions on this one first before we jump on to the code for this one? Like the main idea was first look at only P and try to fill values there. And like you can probably try to form up some conditions based on S and P, but I think this is what I ended up doing, and this is works, and you don't have to deal with a lot of cases here. So this was my idea. Start with numbers 1, ignore all the P, or for the last index you just force values to exist. Whenever you find a P, just create all the permutations in descending order here. And now you start in the reverse order. You keep maintaining the sum of all the elements encountered so far. Whenever you get an S, you see like whatever length you want of last I up to n elements is equal to the sum of first L elements. If that is not the case, then no answer exists. So for example, in this string ss.sp, like I looked at only P and I filled all the numbers in reverse 1, 2, 3, 4. Now I also had this string. So first string was sp. So I filled 1 here, and then there was no P, so I filled all the remaining number in reverse here. Now only P exists. I filled all the numbers in increasing order. This S and P exists. For the P, I ended up filling 1 and 2 like this. And here, like the first 3 characters were this, so I filled 1, 2, 3 in reverse, and then the other number. Like the main idea was first you ignore all the S here, and you try to create the best possible array you can create, so that you can potentially satisfy condition due to S, and you look at only P. So for example, I had this string. So this was the first P we had. So now we know that all the numbers from 1 to 3 should be part of this array. And the best thing you can probably do over here is fill these numbers in reverse order 1, 2, and 3. Now you look at the next P here. So you know that all the numbers from 1 to 6 should be here. You already have 1, 2, 3 here. So for all the numbers, fill it in reverse order from here 4, 5, and 6. Now a next P exists here. So you know that all the numbers from 1 to 7 should be a part of this array. You have already filled number from 1 to 6, so just fill 7 here. And there are no P's, so fill all the remaining numbers in decreasing order here, 8, 9 here. This is step 1. Create an array by looking at only P. And try to make it as best as possible. The best idea is keep numbers in reverse order so that smaller number appears later on, and you can probably satisfy condition due to S. That is step 1. Step 2 is Once you have created this array, start from reverse, and for each s, check if the array you have created satisfy the given conditions or not. So here, like, s appears only once here, so you have to check is this a permutation from 1 to 7. There are many ways to check if this is a permutation or not. You can probably iterate in the complete range and check if it's a permutation of 1 to 7 or not. You can maintain the sum of numbers from 1 to n, check if it's a permutation or not. You can also check if max in this array is equal to L or not. So these were some ideas to check if the array is permutation or not. And the way we have created this array, we know we have filled only numbers from 1 to n here. So the max or a condition like sum would be enough to check if the suffix is a permutation or not. So that was the step 2. Step 1 is create array by looking at P. At P. Step 2, check if it satisfies given condition. It satisfies. If yes, print yes, otherwise print no. And essentially that was the idea. Like you can also maintain max here. That was the idea on this problem. Any questions on problem B before we move to the next problem? I think I can submit this code as well. Okay, submission has not started yet. No, like this one does not have edge cases, and overall time complexity is order n here. Like the edge cases start appearing when you look at the index of S and P and try to form some conditions there, which we did not do anything here. Yeah, like min, max, max, right? You can probably do, but I realize we will end up with more cases and a lot of cases there. And I found this solution to be a bit neat here. And that was the one reason, like earlier, I was also thinking about some min, max, etc. And I realized it would have cases, so I jump on to the next problem here. And when I came back, I found like this would be a bit easier. Now, this problem, if you do it this way, there are no edge cases here. If you try to form some condition based on number of S, number of P, S appears before P, after P, the minimum index where S appears, maximum index where P appears, you can have edge cases there. Okay, yeah, like this solution is also a bit neat. It says if the first character is replace it with a dot, because you know that complete permutation will always be a permutation of 1 to n. If the last character is P, replace it with dot as well, because you know that 1 to n will also be a permutation if you are creating it. So this first character as S and last character as P does not make any sense. Now look at all the characters ignoring dot, and it says either all the characters should be P or all the characters should be S. If that's the case, print yes, otherwise print no. This is a even more easier solution. Like here the solution says we have this condition, right? S dot dot P P dot P, something like that. It doesn't make sense to have this, you know, like this condition will always be satisfied. So just ignore it, because all the numbers from 1 to n would be appear in the complete array. This P also does not make sense because all the numbers from 1 to n will appear at this. Remove it as well. Now look at these characters. Either this should have only S or this should have only P. How to come up to the conclusion that S and P cannot appear over here? Like the idea is, if this is S, some things appear, then one should appear on this side, right? This S says one should appear in this range, and any P here will also say one should appear in this range, and there is some number remaining here, and there are some numbers remaining here as well, and that's where you can probably have a conflict, potential conflict. Like you can probably try to put one here, but you won't be able to get everything here, probably because of the length we have. And like that was the idea people had. Like you will always, like, these are the only common set of numbers you will have between these two numbers, and whatever extra appears here, same should also appear on this side. And you cannot have repetitions in a permutation. Like this part, to make S as permutation, this will have some numbers. To make this a permutation, this will have some numbers, and there will always be a overlap between these two parts. So any questions on problem B before we move to problem C? Okay, next problem is problem C. Okay, I will wait for 15 seconds more if there are any questions on problem B, otherwise I will move to problem C. Okay, problem C says MEX cycle. You are given an integers n, x, and y. There are n dragons sitting in a circle. Dragon 1 to n are number 1 to n. For each I, dragon I is friend with dragon I minus 1 and I plus 1. So you have a circle. You have a circle of folks like this. And basically it says 0 dragon is same as nth dragon and n plus 1 dragon is same as 1 dragon. Basically it says n and 0 are nearby each other. Additionally, dragon x and y are friends with each other. If they are already friends, this changes nothing. Note that friendships are mutual. So it says apart from this circle friendship, there is one more friendship between two folks, which looks like this. Now, once you have defined the friendships, it says we have to output n integers a1 to n, such that for each dragon, the value of ai would be max of all of its friends. And that is the problem statement. And I think I can go ahead with the way I tried to solve this problem. Any questions on the problem statement first? And it says like answer will always exist for any of the constant. We have to just print the values. Okay, when I was analyzing this problem, let's try to first solve the simple problem where this edge does not exist and see if we can create the required array or not. That is, we can try filling. We can first try filling with 0 and 1. This is one possible error, right? All the friends of 0 are 1 and all the friends of 1 are 0. So now when you take max of 1 you will get 0, and when you take max of 0 you will get 1. This is one possible find, but the problem happens when, let's say, you have, when you try to fill 0 1 0 1, it ends up being like this. Now this is a potential violation here, right? So my idea was to replace this with 2 here. Now this 2 has nearby 0 and 1. This 1 has nearby 2 and 0, which is fine. This 0 has nearby 1s. This 1 has nearby 2. Like, for the simple case, when you have a circle, the idea is try to fill 0 1. Either you have enough number of people such that 0 and 1 are nearby, and if you end up with the cases like this, then you can just replace the last person with 2 here. This will satisfy the given constraint. Any questions on how to solve this problem assuming that there are no x and y? Like, we have only one circle. No, like, the problem was definitely tricky. And let's see what happens when we have x and y. Like, x and y will potentially create one edge like this. Okay, please explain once again. My idea was first try to solve when we have only one circle, no x and y here. The idea was I start at 1%, give it 0, next person 1, next person 0, 1, 0, 1. The idea is the place where I would be putting 1, all of their friends would be 0. And place where I would be putting 0, all of the friends would be 1. So if you look at the max of array which only contains 1, the max would be 0. And if you look at the max of array which contains only 0, you will get 1. And this is how you will end up being here. And this is one possible valid array. The problem happens when you try to fill it, but let's say 0 1 0 1 0 1 gives you a case like this where we have two nearby zeros. Now here if you look at max, the max here is 2, and here if you look at max, the max here is again 2. Like, when just 0 1 0 1 0 1 does not satisfy you, you can replace this with 2 here. Like, for the last, when you are filling the circle like this, whenever the last number becomes 0, and if there is a conflict because of 0 and 0, then that person will have 0 on one side, 1 on other side. You can replace it with 2 and you are good. And any questions on how to solve it just for one circle first, before I say how to solve when you have x and y in between? No, like, I was trying to look at like what all combinations I can try over here. At first I did not even read the problem and I was assuming we have a general graph, and I did not have any solution there. Then I realized there is only one edge. Now I will probably move to x and y. What x and y does is you have one circle here and you potentially have a friendship group like this. That's the only thing x and y does here, nothing more. Like, this orange line can probably be rotated, it can be between these two guys, something like this, but overall it's how it is. You have one circle and there is few guys like this. And the idea is, if you look at it in isolation, this is one circle and this is another circle. So this problem is like solving the problem for two different circles which have two elements in common. Any questions there? And now I will try to use the previous solution here again. Like x and y, just you have one original circle and x and y just makes one cut in between there. So now you have two kind of circles there. Like you call it semicircle, chord, arc, whatever you want, but essentially that's what is happening here. And the idea is again same. You make one of the endpoint of the circle 0 and try to fill again here 0 1 0 1. Just ignore this point for now. You also fill the circle here 0 1 0 1 here. And now when you are like in this circle, like on x, you can just say put 0, fill all the elements as 0 1 0 1 like this. And now the idea is, for this element, try to compute max here by taking these two values. Find the max of these three values and just fill it here, whatever it is, 0 1 or 2, just fill here. And essentially whatever value you fill here and you get here would be a correct answer. Now you can try to verify it, but that was the whole idea. Put one element of the circle as 0, fill 0 1 0 1 in the remaining part, and when you have this last, fill this element at last by looking at all the three neighbors it has. Like what are the potential cases here? This would be x, this would be y, here we are directly putting 0, and on this side, if you say, let's say you get a 0, this side also you get a 0. Then when you try to find the max here, you will get 1 here. Let's say this side you get a 1 here. If you get a 1 here, then there would be 1. Like let's say this is 0 here. Then the nearby person here is 1, nearby person here is 1, nearby person here is 1, nearby person here is 1. So if you fill 2 here, if you fill 1 here, everything is still satisfied. Or another case can be one side you have 0, one side you have 1. And you will get here 1 only if you had a 0 before. Here also 0 1 is there, here also 0 1 is there. Now if you fill this place with 2 as well, then also all the conditions will be satisfied, because for this 0 nearby persons are 1 and 2. For this person nearby persons are 1 and 2. For this person nearby persons are 0 and 2. Or like the other case can be both the sides have 1. Then also this will work fine, because this one exists, then a 0 before it also exists, and you can probably fill here 2. For this person 2 would be the max, because 1 and 0 both exist as its friends. For this one, the 0 will exist before. For this one, a 0 will exist before, and the next part is 2, and everything here. And essentially that was the idea. Any questions on this problem first? And essentially this was the overall solution I had for problem C. To repeat the idea was, first solve it just for the circle case, and the idea is you fill 0 1 0 1 everywhere, and if there is a conflict you fill 2 at the last and everything satisfied. Then the idea was to look at xy relation as two different circles here with their two elements as common. And the idea was to make one endpoint of that circle 0, fill everything there, and for this endpoint try to find what the max should be by looking at three neighbors here. And whatever 0, 1, 2 appears here, after case analysis you can verify that whatever value you will get, you final array would be something that will satisfy the given constraint. That was the only problem statement here. Any questions on this before we move further? Like, I think you can probably look at again Rubicon's implementation. He also did the same thing. Like this, he is solving it for circle by just putting 0 and 1 if n is odd. Otherwise, what he has probably done is for I equal to x, he put 2 there, and for all the other numbers, he tried to put 0, 1 on the nearby side. Like some case analysis here, but yeah, he just essentially filled I for I equal to x2, and for everyone else, just fill the trail of 0, 1, 0, 1 there, and this essentially ended up solving the idea. I think, does anyone has simpler implementation? Man, what did Anton do here? Okay, Anton also did like basically replace with distance from 1 and probably replace 2 somewhere if required. So yeah, like Rubicon's solution was like he explicitly knew which cases have 2 and which cases have 1 in the Y graph. So he just added 2 if else based on that and printed it. And I think everyone else pretty much looks like this. Mridulahi, we can also. And like a lot of people have wrong answer on 1. Something like that. Yeah. Any questions on problem B? Like I can also show my code here. My idea was to first look at it as a circle where 0 and D are friend, where D is the distance between X and Y. And then what I did was I started filling from 0 up to D with elements 1 to N. And I also filled the numbers from the reverse up to 1 to N. And for the element at D, I filled the max of all the three nearby neighbors. And then I rotated the circle to make it X and Y instead of 0 and D. So that was the solution here. And then there was some checks to verify if it's working or not. Any questions on problem C before we move to problem D? Okay, problem C. Any questions on problem C? And I think someone asked problem B. I did not understand how subarray is related to doubt. Like the idea there was you look at the subarray, then you look at the length of that subarray you want, and you have to verify that all the numbers from 1 to that length appear in that element only once. Any questions on problem C before we move to problem D? I will take 15-30 minute pause if anyone has any questions before moving further. Okay, I think I will start with problem D now. Problem D says shift plus escape. You are given a grid with n rows and m columns of non-negative integers and an integer k. I comma j denotes the cell from ith row from the top and jth column from the left. For every cell ij, the integer aij is written on the cell. You are initially at 1 comma 1 and you want to go to n comma n. You can only move down or right. That is, if you are at I comma j, you can only move to I plus 1 comma j or I comma j plus 1. Before you begin moving, you can do the following operation any number of times. Choose an integer I from 1 to n and cyclically shift row I to the left by 1. And some formal definition is given. And it says we have to find the minimum cost from 1 to 1 comma 1 to n comma m. So any questions on the problem statement, anyone, before we move further? Like, let's say we did not have this option of minimizing I comma j, then what would you have you done here? If let's say we do not have to do any rotation, then problem becomes a bit simpler. Notice that you can only go to the right or down over here. So like someone mentioned Dijkstra, but that's not required, to be honest. Like you have this grid like this. You can start filling the minimum distance here. To reach here, the minimum value you can get is the value present here. And you start filling values like this. When you want to reach here, you will come here either from this cell or this cell. So just look at the minimum value of these two and add current value to it, and that would be the minimum distance to reach here. Or for example, if you want to find the minimum distance here, you can come here from either from the cell just above it or from the just left side it. So you look at minimum distance to reach either this or this and add current value to it, and that would be the minimum distance to reach here. Any questions on how to solve this problem if we don't have minimum constraint? Like if we don't have, if we are not allowed to rotate the cells. And like the problem statement says, we have to first decide what all rotations we want to do, and then only we will start moving. I will do it in a different way. What I will do is, before going to a new column, before going to a new row, I will first rotate it as much as I want, then I will go to the next row only, and I will go then right. Like instead of rotating everything at first, what I will do is I will start from some cell 1 comma 1. I will go to right. Now let's say I want to go down. Before going down, I will rotate this row here to, let's say, like this. Then I will go down here. I will go some more nodes like this. And now when I'm going down, before going down, I will rotate this row in the way I want. And that is still same. Like once I find minimum cost like this, I can see what all rotations I made to reach n comma n, and I can just say like I want to do these rotations before starting. And this makes life a bit easier. Like you don't have to fix the number of rotations you want in starting. Any questions here before we move further on how to solve this one? Like any questions so far? Like how to solve this problem if we do not have any rotations? and then how to solve, like, and if you want to do rotation, the idea is do it after every value, like before jumping into the next row. Like now my idea is do it row by row. My idea was, let's say these are the rows we have. First I will find minimum cost to reach at all the cells in this row. Like I know minimum cost to reach this node, 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 minimum cost to reach this node. Now I will try to find similar cost for the row just below it. And the way I would be doing is, first I will keep this row as it is and I will run the same DP. For this node, find the minimum cost to reach here. There is no left side. For this node, try to find the minimum cost to reach here or reach from here. For this node, try to find the minimum cost to reach here or minimum cost to reach like this. Or for this node, try to find the minimum cost to reach either from this side or this side. And compute this for all the values. Step 1. Save this answer somewhere. Now rotate this row by once. And like the only difference you will make here is, now when you are trying to find minimum distance from this, add k here to signify that this row was rotated once. But you find like there is no left side. If you are at this node, you add, try to find minimum cost of this plus k and the value here, or you find minimum cost to reach from here. If you want to try for this one, you can try to find minimum by add k and try to find minimum cost like this or a node from here. And that was my idea. Like when you are doing the jump from here, add k there. If you are doing from here, don't do anything. And essentially that was the idea. Now I have find the minimum cost to reach all the nodes after rotating it once. Then the idea was, now do a rotation here 2 times. And now whenever you are doing from here to here, add 2k to your cost. There is no left side. If you go by this, you should add 2k of this value and then the cost of this value. If you want to find the minimum cost to reach here, you look at this value, add 2k to it and current value, or you look at this value and take minimum of these two. Jump from here would be of 2k cost. From here it would be no cost and add current value. And this way I tried all the possible rotations here. And then I looked at for each cell what was the minimum for any of the rotation. And that ended up giving me the values like this. And then row by row was the idea. Any questions on the idea before I jump onto the code here? Okay, I can also show the code here. Like the idea is, first take all the numbers as input. To memorize on step, I am using multiple vectors. First was the DP vector, which is the value for previous row. To start with, you can say like only the first row is allowed. I have 3 values. Current row DP, and current rotation DP. 3 different DP vectors. So the idea is I first fix the number of rotation here. Now I initialize current rotation dp as everything is infinity. Now I go for all columns from 1 to n. The current value here would be whatever row we had, like number of rotations to find the value there. This would be the current value, and current rotation minimum would be value of this comma k, the number of rotations you did if you are jumping from the value just above it, and whatever the current value you have. If you also come from left side, then current rotation dp would be whatever value you had plus the dp in current rotation from the nearby and whatever current value you have. And then you can also replace it. You have computed everything here. You can replace current row EPC with and whatever the current row, whatever the minimum value was with current rotation. And at last, you replace previous row DP with the current row DP and try for the next row there. And at last, you print whatever minimum you got to reach the last row. That was my idea for problem D. Any questions on this one? I hope system testing is over, so I can probably submit code here. Any questions on problem D? Like E would be the last problem we will discuss today. And like as like E was an interactive problem, and you would have guessed right, it was a binary search problem. Like interactive problem, most of the time on Codeforces are binary search problem. Like you might find some memes probably here. Like corporate wants to know the difference between binary search and interactive problem. Okay, I'm surprised no one posted that meme here. So, any questions on problem D before we move to problem E? That would be the last problem for today. Like, I don't really know how to solve F. Okay, I will start with problem E. It says this is an interactive problem. There is an hidden binary array A of length n, where n is the power of 2, and an hidden integer k. The array contains exactly 1, 1, and all the other elements are 0. Two integers L to R, define their sum as the values from AL to AR. You have a magical device that takes the range and returns the range sum, but it returns the opposite result when the range has length at least k. Formally, in one query, you are given it a pair of integers L to R, and it will return either 0 or 1 according to the following rules. If the length is less than k, then it will return the correct sum. But if the length is more than k, it will return the opposite sum. If the sum was 1, it will return 0. If the sum was 0, it will return 1. And you have to find k using at most 33 queries. Then it says device is not adaptive, blah blah blah. So like, how do you solve this problem? And one more thing was like, n is up to 2 to the power 30 and total queries are 33. So it's like we have to solve it in log n query plus 3 extra queries we have. So we can afford to waste 3 queries, but we cannot waste the fourth query. Like, it involves a bit of casework, but at the end boils down to some binary search. Any questions on problem statement? Okay, the idea is as follows. Let's look at the complete array of length 1 to n. Let's split it into half. One half this, one half this. And whatever the case, we know the total sum is 1. Like, basically, let's find, like, what I'm saying is, our query, whatever result will it give, either this side would be 0, this side would be 1, or this side would be 1, this side would be 0. Like, one of the side would always be 0, one of the side would always be 1, irrespective of how we have set up. Like, because you see the length is same, and you know that only one exists. So either this will return the correct sum, and both the sides would return correct sum, or both the sides would return the inverted sum. Whatever they are returning, it will always be the case that one of, if you look at n by 2, this is n by 2 line. One of them will be 0, one of them would be 1. That was the first step. And my idea was to pick the side which returns 1, and then also query for half of this too, of n by 4 length. Like, first query just half of this array, the place where you get 1. Now query for half of that side. And if you look at it on the bigger picture, it will look like this. This is 1 to n. This is 1 by n by 2, which is 1. And then now you have queried, like, there can be different cases here. This can be 0. This can be 0. This is of length n by 4. Case 1. Let's call it case A. Case B is one of these is 0, one of these is 1. Case C is both of these are 1. Like, I am using X Kali. And the question is, this is an happy case. Whatever it returns matches with the sum we know here. If we say both the sides are 0, but we know that our query has written the sum of complete array as 1. This says like the sum is 0, but our query says the sum of this complete array is 1. So these are bad cases. And this is a good case. And the crux of this problem was, based on whatever feedback you have got here on ABC, you can try to find some ranges of k. If this is the case, then you know for sure that this half contains only 0, and this one is wrong here. So your k would be less than equal to n by 2, but k would be greater than n by 4. And now this is an happy case. And if you get an happy case, then you know for sure that k is less than equal to n by k is greater than n by 2. Because for now you have queried n by 2 and n by 4 and you got correct results both of the time, then you know that your valid value would be more than n by 2. This case means this one and this one is also wrong. All three of these are wrong. So in that case, you know for sure your k would be less than equal to n by 4 because you have queried n by 2 so far, n by 4 so far, and you got wrong answers on all the three queries. Now the idea is based on these three cases, you try to binary search on these ranged on null. Now the question is how to do binary search. I will jump back to it again, but like, do you understand like how based on the complete sum 1 and half sum as 0, 0, 0, 1 or 1, 0, you found different ranges here. This 0, 1 or 1, 0, anything works here. And here you know for sure that this complete array will contain 0. Here you know for sure this complete array will contain 1 because you got correct result both the times. Here also you know for sure this complete array contains 0. Like the idea is to solve these three different cases. This is the full array we have. Case 1 is when between values are between 0 to n by 2. This is the first half 0, this is n by 2. And you know k is between n by 2 and n by 4. And the idea was you can just binary search on these length here 1 to mid. And you see what does mid returns. If mid returns 0, then you know that your correct value of k is more than this mid. If this mid returns 1, then you know that your correct value would be less than mid. Because you know that the correct answer over here is will always be 0, whatever you do query on this part. So based on what you are getting 0 or 1, you can try to binary search on the value of k and print it. Any question on this case? This is case A. And the next case we had was like the correct value was greater than n by 2 and this part contained 1, we know for sure. Again, let's draw it between 0 to n. We know that we have checked over here this value contains 1 and k is greater than n by 2. This is the mid we have. The idea was we can again do a binary search here on this part like this 1 to mid. And because you know that 1 is on this side, the correct answer is always 1. So if you get 0, you know that your mid is more than the value of k. You got 0, then you know that your mid would be less than k. Again a binary search. But on this side. Any questions on case B? Similarly, the case C is where you got all as 1. So you know that your correct value is less than n by 4 and the value is 0 there. So this is essentially same as case A. You just instead of n by 2, your value is between n by 4 and that will contain only 0. So you can use the similar binary search here. If you get mid as 0, you know that your k is more than mid. If you get 0 to mid as 1, you know that your value of k is less than mid. That was the idea. And The another case was identical, where instead of 1 0 you get 0 1, whatever you get. But essentially that was the crux of this problem. Any questions on this one? Like, there are three different. First, you use three queries to find some range of k, and then you use binary search on some different portions where you know that one definitely exists in every query or zero will definitely exist in every query. And that was the idea I had. And one more thing I did was I even stress tested it by solution for different random values of k and 1. Like, you can probably refer code to see how to debug interactive problems over here. The idea is we have one query. I have globally defined one db value as false. If I define it true, instead of reading it from input, it just tries to predict what the correct value is. So a self-written judge here. Query takes L2R, prints those values, and returns the sum by reading as input. If I want to debug it, instead of reading it from input, I just calculate it on the fly based on where 1 is and what the correct value of k is. Now I first look at the value of both the halves, and based on which half has 1, I look at values of n by 4 length of that half. So if both the halves has written me 1, I try to solve for 1 to n by 4 case, ensuring that whatever range I will query will always have 0. If both the halves are 0, I query for the case where the value is n between n by 4 and n. And if one value is 0, one value is n, then I query for the case when the value is more than n by 2 but less than n minus 1. And then a solve function, a literally binary search here. Look at this value, which takes LR as input, some parameter on where to read from, and what would be the correct result in case k is less than that. LR, look at mid. If querying from 1 to mid gives you the correct value, then you move the left pointer, otherwise you move the right pointer, and at last print the right value. Here I am essentially printing the right value. In case I am debugging as well, then I just verify it with whatever value I have taken earlier. So this was my solution for problem E. And I think I can reduce one query here. Any questions on problem E? I think this would be the last problem I discussed for today. And before I call it a day. I think for my setup, I am using one script from Eknawala. Like, if you comment, I can probably comment that as well. So I'm using these two things. This is for downloading the problems. And this is potentially a make file here. This is for running debugging all the tests. In case of doubt, you can probably see how others has debugged it. And then one competitive programming extension, competitive companion. So I think this is what I have as a bare minimum setup to download all the test cases, run, pass, and debug. I think I don't know how to solve F, so I will skip it. But any questions, anyone related to this contest or anything in general before we call it a day? Someone was asking about the whiteboard. Like for a whiteboard, I use this xcalidraw.com and a graphic pen. Thanks everyone for joining today. And I think this is all I had. Thanks everyone. Bye.